This is the second of a series of videos on graphing exponential functions. And on this particular video, we focus on graphing exponential decay functions. So first, let's look at the exponential function. Y is equal to a b to the x. And just for purposes of simplicity and clarity, we're going to focus on when a is positive. In the following video, we'll talk about when a is negative. Well, when b is greater than 1, then that's called an exponential growth function. I'm sorry, when b is greater than 1, that's called an exponential growth function. And when b is between 0 and 1, we call that exponential decay. And the graphs of the two are going to look fairly similar. Both of them are going to have y-intercepts at a0. I'm sorry, 0a. Both of them are going to have asymptotes at y is equal to 0. But where they approach asymptote is going to be different. When it's exponential growth, that's what we saw in the last video. We noticed that it started at 0a and it increased exponentially, but going backwards it decreased and it approached an asymptote. Got closer and closer to the line y is equal to 0. When b is between 0 and 1, the way it looks is that it now starts at 0a and decreases, approaches the asymptote, y is equal to 0, and then comes back this way. So the thing you want to do is you want to kind of memorize those two basic graphs. And we did this one in the first video, graphing exponential functions, part 1, and this is in part 2. So let's do an example. And let's graph y is equal to 10, 0.8 to the x. Now the steps are going to be the same. The first step is you're going to find the y-intercept, or the starting value. Remember, for the y-intercept we know that x is equal to 0, so then you have y is equal to 10, 0.8 raised to the 0. Any number raised to the 0 is simply 1, so that's y is equal to 10 times 1, or y is equal to 10. In other words, the y-intercept is the point 0, 10. The second step is we're going to find the asymptote. And again, the asymptote is just like it is before. The asymptote is always going to be just simply the horizontal line y is equal to 0. And the third step is you're going to do a table of values. So the basic idea of what a graph is going to look like . Here's your x-axis and your y-axis. Then you have the y-intercept here at 0, 10. And you're going to have an asymptote here at y is equal to 0. And in this case, since it's exponential decay, we're going to see that the graph is going to look something like this. But we'll also see that when we do the table. So let's do the table of values now. So again, we already know that the y-intercept is the point 0, 10. And we know that there's an asymptote at y is equal to 0, so let's do a table. Have x values and y values. Let's put the intercept in the middle. That's 0, 10. And let's choose two x values that are larger and two x values that are smaller. They don't need to be equally spaced. It's very important when you graph parabolas, but here they don't necessarily need to be. So now how do we do this? We plug in x equals 2. So we have y is equal to 10, 0.8 squared That's 0.8 squared. Remember, you have to use the PEMDAS rules, and since you're using the PEMDAS rules, you do exponents first, and then you do multiply, and then you multiply that times 10, and you get 6.4. In this case, exactly 6.4. And now let's plug in y is equal to 5, so that's 10, 0.8 to the 5. That's 0.8 raised to the power of 5 times 10 at about 3.3, and that's going to be an approximate. Now when you do negatives here, that's 10, 0.8 to the minus 2. That's 0.8 raised, parentheses, negative 2. That's 1.56 times 10. You get about 15.6. Now let's do the same thing with 5. 0.8 raised to the negative 5 times 10. You get about 31 or 30.5. That's y is equal to 10, 0.8 to the minus 5. Now you simply plot the y-intercept, the asymptote, and the table of values, and then you'll be able to do your graph. So let's go ahead and plot that. Now one difference is that oftentimes this will be too large for your graph paper, so you can still use graph paper. You just have to think carefully about how you're going to do your estimates. I'm going to do y is equal to 10. I'm going to do these by 5s. So that's 10, that's 20, minus 10, minus 20. So the first point you do is 0, 10. 0, 10 is going to be right here. And I'm going to go ahead and label that. Then I'm going to put down the asymptote. The asymptote is going to be a horizontal line. Oftentimes that's not done as a dotted line. I'm going to do it as a pink line. Nothing wrong with that. Though it's not traditional. Label that. That's your asymptote. Y is equal to 0. Now let's plot the other points. You're going to have 2 and 5. 5 is 3.3. So if this is 10, 5 is going to be about right there. 5, 3.3, and 2, 6.4, right there. Your graph is basically going to come down and look like this. And it's going to go up pretty quickly. If this is 10 and that's minus 10, your points here is minus 5 is way up to 30. It's going to be well up here. Your graph is going to look something like that. Probably just label a few points. Minus 5, 30, 1, more or less. 2, 6.4. 5, 3.3. Obviously it's not going to be curved like that. It's going to be a little better curve, something like that, pretty continuous. And that's how you graph exponential decay functions.